This video is about me fixing this hood fan for a friend. When I got this, had only one of the blades, and there's a nut here I was missing, didn't have the other blade. I tried to pull it out and I was not able to pull it out because the shaft was bent. So I ended up drilling holes and pretty much destroying the hub, which was embedded in the plastic here. Then I got the other blade, which is this one, and the nuts. I have the nut from the other side. The nut is a metric 8 by 0.5 millimeter and it has a taper at the end. I'm not sure if you can see there at the end. And the hub has a slitted in 4 bushing, tapered, and the nut is clamping that sleeve on the shaft. So the reason I got this was not moving, was completely seized. So I managed to take the blade out after, damaging it, completely destroying it. And one of the bearing was completely seized. This was the bearing inside. 6 millimeter internal diameter, 19 external, and 6 millimeter wide. And upon inspection, the shaft coming out the other end was so bent that I could not make it straight, could not recover it. So I ended up cutting the shaft. I let a 13 millimeter long, 14 millimeter long stub, and I built another shaft. I press fit it with Loctite 648 permanent, then machine that shaft, machine the hub, and the same sleeve but in larger diameter. I made the shaft on this side larger than was on the other side. The other side bearing is 6 millimeter. On this side I put 8 millimeter interior, same width and same external diameter. And where this bushing sits, the shaft is 7.5 millimeter compared with only 5 millimeter on this side. And then I made this sleeve tapered on the interior and a metric 4 screw to clamp everything in position. Also this hub and the hole in the hub and hole in the fan. So all that follows is me working and trying to fix this motor, this fan. So we go from there. Hey honey, this is the ball bearing. It's done. I mean, see, that's how much it spins. Then I feel high resistance here. So the good news is I was able to open this and we can find this ball bearing. The bad news is I don't know how to remove this shroud. It seems there is a thread there. I don't know if there was a nut which was clamping this plastic thing or not, because I need to figure out how to pull this without damaging it. We need to access the bearing on the other side, right? So we can take them out and replace them. That's what is causing this, right? You see, it should spin easily. It's just locked. It's just not spinning easy. It's done. And I can feel the grease on it, right? So yeah, and I'm touching with this dial indicator at the bearing surface, and I center it between big divisions. You have 1001-25 micron, the small division is 2.5 microns. So we are as centered as possible. So now we're gonna go to the end to see the problem we have there, just at the end there. Okay, let's see here. Let's adjust this until it's touching. I'll make this a 0, let's say. Okay, so let's see if we spin this, how bad it is. You see, it's 375 micron. So that I need to take this cutter, maybe remove this from here, staying in the way. Let's see. Go slowly there at the end, and then give it a spin. Go slow on it until I'm touching. Don't need to take much. Okay, let's do a pass here. Let's see if it fits now. Well, it's in the house. Let me bring that. See if it fits. No, still take some more. Okay, so let's go. More. Okay, I need to put some sanding paper to smooth. Okay, now it goes in. So now I need to focus to make that straight, because it's like face at the end. Okay. Okay, now I need to chamfer. Slowly, because this is not supported at the end, so to go slow on it. Awesome. This part done. This is the other side. It's really bad, and you can see it, how bad it is. So I cannot make it straight. I was thinking to make this straight somehow, but the bearing surface is wobbling, and that will destroy the bearing in short time. So what I have to do, have to cut from here, cut it off, and then come up with I have this precision shaft, 12 millimeters diameter, hard steel, 1655, very hard on the surface, say like 60 Rockwell, and make a hole which is 10 micron smaller than this diameter here. Then it's gonna be press fit and put some permanent Loctite. It's gonna go up until it's touching that surface there, and then it's gonna be a bit longer here, and then I can machine that down until I'm making these features again so they will be in line and centered with the rotor. So I got a reamer today to give me that 10 micron interference fit. So, you know, drill a 7.9 millimeter hole in this, and then that reamer is 7.99, so another 90 microns gives me to 8 millimeter. This is 8 millimeter and 3 microns, and 8 millimeter on and 1 micron on the other side. So I'm gonna have 10 microns interference fit. They will just shrink on the shaft. So this interference, it can transfer 15 Newton meters of torque. This motor, based on its power, needs only 1 Newton meter. So, you know, the clamping force here is high enough so this will never, that sleeve will never spin on top of it. Plus, you have the permanent Loctite. So I'm gonna do that next. Yeah. Let's see how it looks if I start this. Probably bad. The bearing. So before working on that shaft, I thought I'll do a test to see if the reamer is good. This is the reamer. I machined that shaft exactly to 8 millimeters, and the reamer I used to make this hole, and without heating this I couldn't press fit it here, and then I sanded this down by hand just a little bit, and now it's 7.9 millimeters, and now I have a slip fit. So this reamer I have, it seems it's doing 7.9 millimeters. So also I decided on a different Loctite. Loctite 648. It's much stronger. It's for industrial use. Allows a gap of 0.1 millimeter. I don't think I have more than 5 microns here. So it will be enough strength for that. So I'm waiting for that Loctite. I have another Loctite. I thought I'll use that, but this is for threads, and it's medium strength. I had a high strength. I don't know where it is, where I put it. So I'm getting overnight from Amazon the high strength, and then I'm gonna glue this, wait 24 hours, machine it, see what challenges I might have. If that works, I'm gonna do that on the shaft end. I made a nut for this with a tap. It's metric 8 by 0.5 millimeter, like non-standard tap, and I mean, it's threading really nice. I matched the threads. It's perfect. I measured with the magnifying glass on this and checked, what's the pitch, and I got it right. I mean, it threads to the bottom. That's good, but the thing is, it's not clamping. So I'm gonna tighten this to the end. It's clamping some, but it's not, doesn't have enough. See, it's spinning together with the shaft, but I feel it. It's not. See, it's loose. I'm gonna have to think of something. Maybe if you bring me the nut from here, maybe that's better. If not, I will have to do to this what I have to do to the other, meaning take this out, this clamping mechanism, and create a hub with screws, like I said, and I have control on the diameter, and I can clamp here better. So maybe bring me tomorrow the nut for this to see if that's clamping better. I tried with this tape on the threads, but it didn't do anything. I mean, it didn't work. So yeah, see, it's fully threading on complete to the bottom. you can see here. Now you can see. Yeah, it's at the bottom, right? You can see there. So let's try with your nut. If that doesn't work, probably I'll do this. Take this out and do a hub here where I have more control to clamp on that. I mean, the idea to clamp on this I have is to create the hub. Oops. The hub, it's about 1 millimeter per side in thickness, has a cut like this, not two, just one, right, diametral. And then there is a split bushing which goes over that hub, and split because it's split in half, and there are two screws here, one here and one here, and they clamp on these two split parts, right? So they clamp on the shaft, and you know, I can have much higher torque because of those small screws here. That's what I'm planning to do for the other one, because I cannot make this. The thread probably is tapered, like in an angle, and I cannot do that. That was made on a CNC machine or something. So bring me tomorrow the nut if you still have it to try with that. If not, I'm gonna go with plan B. Clamped your nut here. Tighten it with 13. Here goes nothing. Seems it's did its job. Yeah, let's try one more time. It works. Here's the plan for the hub. Need to make this hole round and centered with this diameter. I have this aluminum, gonna machine it to the point that it fits on this diameter here. Then it's gonna be placed here like that, and then I'm gonna use the tailstock. Just push the tailstock against it here, and then using this dial indicator on the surface here, by spinning the chuck, I can make sure it's concentric. And then I'm planning to make 3 holes in this plastic, one here, one here, and one here. Clamp this on the aluminum with 3 millimeter bolts, and then make sure again it's recentered. This chuck I modify is a true chuck, that's what they call it. Basically, the chuck with this ring, they can move in this plane around the back plate. So basically, the back plate has a boss inside, and this is a ring which is mounted with screws on the chuck. And these screws here is 3 of them mount the back plate to the ring. So if I loosen these 3 bolts, then these 4 screws, they push against the boss, and I can adjust the chuck to be perfectly aligned, right? So once I mount this here with the screws, I'm using this dial indicator and adjustment in the chuck to align it perfectly, and then I can use a boring bar to make that that hole. Where is it? Here. It's a boring bar. Just go with it, you know. Advance slowly, bore a little bit. And the reason I'm doing this with the aluminum is to offer enough support on that flat surface on the back. And also while I machine this, right, it stays you know, on that aluminum surface, so you're not flexing or moving on me, right? So I'm gonna bore, basically gonna do a hole in this. Should be smaller than this hole, and this boring bar will machine from the aluminum and from the plastic in the same time until I get this hole nice, and then I can machine the hub, get it mounted, and we move from there. So I'm gonna do this next because I don't know how it goes. The other part left with the rotor, that I know how to do the press fitting, you know, to machine that shaft. But this is in the unknown phase. If I get this right, then, you know, we are all set to do all the changes. Okay, so I have this aluminum machined, faced and cylindrical. I mounted this here. I have this support, tailstock support on a bearing, and I have a bearing here. I'm gonna push towards this ring to center it as it spins. I see it's kind of wobbly. I mean, I can push here, see how it realigns some. Okay, so you can see that now it's aligned on this ring. And release. It's kind of wobbling. And another problem is I don't have access to make those holes from here. So I need to change the plan. I think I'm gonna do something else. I'm gonna drill a hole there, thread that, make a flat washer, and clamp that flat washer like this wide. Clamp it on the clamp the plastic between the washer and the back aluminum, and then center it here with this bearing, and then make those 3 holes, and then remove the washer, and then make the hole around. I don't see how otherwise I can do this. Managed to make this washer and bolted this with 3 screws. It doesn't look like it's wobbling that much now, but I can see it here. So if I put it here, some deviation. This dial indicator, 1 big division, and 1 small division is 0.5, so 12 microns. So what I'm gonna do is I'm gonna adjust from these 4 screws, 1, 2, 3, 4, like opposing, you know. So align this here with the dial indicator, 0, and then move 180 degrees. See what my deviation is, like what we have now, 1,500. So make that 0, and then do the same with the other 2 screws, this one and this one. I don't think this ring it's round, so I'm gonna do that now, and then I can remove this nut and machine that. 0 here. On the other side we are 5.5. Okay, so I need to move this, which direction? This way. 1, 2, 3, no, the other way. 1, 2, 3, a little bit, and then where's my bench? Okay, so I need to adjust this until I see 0. Okay. Okay, let's see. 0. Still have 2000. Okay, actually 1.5. So that's 0. There, 0. 2000. Okay, so I need to move 1000. Okay, and then loosen this, move this one. Oh, the other way around. Okay, yeah, that's 0. Okay, so now the other two. We are this on 0. On the other side, it's 1000, 1.5. So about this much. Okay, so that's the best we can do. On two of diameters 90 degrees apart, we are on 0. This is not round. Okay, so now we need to tighten this back, lock the spindle. Okay, 1, 2, 3. Now I can remove this. Oh, I should do the spindle locked. Okay. Okay, back here. I'm gonna bore this out now. So I need to put a stop. Let's check if I have enough clearance here. I'm at the limit here. Let's see. Clearance. Okay. Going slow. Yeah, it's working. More. It looks like it's clean all around. To don't feel anything. Yeah, seems it worked. Looks like it cleaned the full surface. Okay, it's out. I have a hole which is centered. That's where it was mounted here. It's centered as much as we could on this ring. So now I need to make the hub. I need to find this diameter. I have no way to measure it. So what I'm gonna do is machine this, test until it fits this diameter here, 28 millimeter, I think, 27 to 28. So reduce the diameter, then remove the chuck, mount this in here, mount it on the spindle, and then machine slowly until I get this going in, and then I can measure what the diameter is. So we're gonna do that next. Have some parallels to make sure this stays parallel here. Not that it matters that much, but okay, take this out and let's go to town. I'll spray some WD-40 for lubrication. And then just gonna go this much. Put a stop here for the carriage. That's the portion I'm going to machine. 27. Okay, 40.0. Go 15,000. Let's see where we are. 36.3. 36.3 minus 27, 9.3 on diameter, divided by 2 on the radius, divided by 0.0245, 1/1000 of an inch. I need to go 183 divisions. Okay, so I'm at 0. It's 20. 60. 80. 100. 120. 140. 160. 180. 150. 27. 27.11. I think that should be good. Let's see. Oh, now it's clamping. Yeah, I did a mistake. This is 27 to 28, so I chose the smallest one. Maybe I should put a 26, 27 instead. Oops. Let's try 26, 27. Only if I can find it. Where the heck that is? 29, 23, 24. That's the one, 26, 27. But I'm over. I'm 26 and something. So I need to take how much? 27.07. Okay, 06. So that's about 2-3 divisions like that. Yeah, that will clamp it good. Let's try with the collet. Yeah, that will do it. Okay, so now can take this out. Remove the chuck. Okay. Okay, this is out. Let's put this in. Okay, that should be good. Okay. Remove the stop. Okay, this is not centered here. this much. Carriage stop, and I go to town. More. Yeah, not yet. How much do I have? Damn, I need to sneak on it. I don't know what the diameter is. Can I measure shit? Can I approximate this shit or not? 21 and something, 21, okay. And this one is what? 26. Okay, so go 4 millimeters and then go slow. $25. Almost 24. Yeah, maybe go half. Okay, we're getting closer. Actually, it's the other way around. closer. Okay, to go slower. That's it. That's the diameter. Tight fit. Awesome. Okay, I made this flange. Goes here. So I go like this. And then there is 3 bolts, 120 degrees. This, I will machine this at the end, I mean cut it off. But I need something to hold on while I machine the steel insert, and when I make that slit, so I'm holding it up to the end. That's tight fit, all of them, so no play. There's no play. Does have room to wobble. So now I cut this piece and I need to machine it and press fit it here. Not sure how round it is. Probably I'll just machine the surface to a well-known diameter, match the diameter here with 10 microns interference and press fit. It's gonna go something like this. This is gonna cut off, so I don't need to protrude too much, just a little bit. This is the useful portion, probably this much, where that slit is gonna be on a reduced diameter. More fun. As I was suspecting, this is not round. See, 15.835, 15.865, 15.879. So it's like 30-40 thousandths off, while I need 10 microns interference. This is not round, so I'll have to machine it, make it round. This is all over the place. Yep, looks like I might get away with this because it's not that much. It's 1/1000 of an inch, so I think that's good enough to do a press fit. Okay, we made it round. I measure with the micrometer and I have the same dimension down to 1 micron from here to here. So I think that should be enough, because it's not gonna, where, this direction? No, this direction. That's how much we're gonna press fit from this side. So I need only this portion here, press fit. And yeah, I'm gonna do this next. Press fit, put the Loctite 648, so I get 24 hours to harden. We are in like Flynn. So now we wait 24 hours for this to harden. And then we can machine here, diameter, cut to length, and the internal diameter I will match it exactly with the shaft. Okay, so I measured, I need to cut 2.9 millimeters to get it to length. I'm gonna touch here and then 0 the DRO, so I know I will go 2.9 millimeter when I move the carriage, be exactly on dimension. I call that 2.9. Next, center on the surface and make that precise hole which goes press fit on the rotor. Well, didn't work like planned. I drill with 4.5. This is a 4 millimeter boring bar, so I thought it will fit, but as you can see, it's not fitting. So I'm gonna try with a 5 millimeter. Try again. It's done. Press fit joint compound, waiting 24 hours. Centered here on that shaft, on that stub, this center, so should be all aligned. And anyway, I have to machine this, so that will ensure concentricity, all the rest of the features. So tomorrow, what's the time now? I don't know, 9. Okay, it's probably Sunday. I can work on this. Okay, so I'm about 12 hours after I put joint compound and I release it. I cannot machine it yet. I put a blue dye. That's where the bearing journal is gonna be. And this portion here is where the hub will get mounted like this. This portion goes away, so it'll stay like this. And this I need to cut to be the same length here. But the challenge I'm seeing here, if you see, it's wobbling. Even when I mounted it, it was centered here. So I think what happened with that stub there was not perfectly aligned. I didn't machine it to be in line because it was too small diameter and I didn't want it to reduce it even further. So when I put this in and I pressed it with the tailstock, it stayed aligned, but then after release, it sprung back. So now it's not the way I wanted it to be. If you look here, gonna move quite a lot. So with that said, I cannot machine it relying on this center because it will pull it in, align it with the axis, machine it, and then goes back and it will wobble. So what I need to do that now is to recenter it. So the only way I can do that is make this hole a little bit larger than it is, the hole at the end. Focus here, and use a small boring bar, go in a 60-degree angle and just machine, that angle that will be symmetrical around the machine axis, and then I can center it again with the tailstock and then machine the features. Can't do that now because I need to wait 24 hours, so I'll wait tomorrow. And I have another idea. Initially for this hub I thought I'm gonna machine it to size to match the diameter here, and then cut a slit on diameter and then use a clamp here similarly with this, but slit in half with 2 screws. But I changed my mind. Actually I can do something better. What I can do is machine this surface conical, 2 degrees angle, and then machine a bushing which has the same conical surface, and then put a metric 4 or metric 5 screw here. So when this hub stays on the shaft with this slit and conical, that nut, it's gonna push on the taper surface, and I'm gonna clamp this here. And also here there is a shoulder, so this doesn't go anywhere. So gonna be strong enough to push it to the shoulder and also clamp it here with just 1 screw here, which would be better because at a smaller diameter I don't have to worry about any out of balance on this aluminum thing clamp I was planning to do here, and much easier to disassemble. Just 1 screw, untighten this and this comes loose, instead of the clamp with 2 screws here. I'm gonna do that instead. So tomorrow. I have an end mill here. I cannot make a 4mm hole with a drill bit because it will follow the center drill I use, so it will be unaligned. So I'm using a 4mm end mill to go inside about 3-4 millimeters and then remake that center. Okay, I think I need to go more to see with the magnifying glass how much I mean. Yeah, probably need to go a little bit more. Yeah, I think that's good enough. Let's see if this fits inside. Yeah, I think it will fit. So now I need to align this. I have a 30-degree square here fixed with 3 magnets. So I need to align this edge to be in line with the machine axis, and then I can make 30 degrees when I move this carriage. So I'm gonna do that next. So I have aligned the carriage. If I move across that surface there, stays on 0, which means that my angle here is 30 degrees, so I can machine that hole. I'm gonna do that next. Okay, I think we have a good surface there. So now let's bring the tailstock and see what we got. Yeah, I think we're gonna work. The question is, are we seeing any movement when this engages? No, goes perfectly straight. It's not pulling on it. Goes perfectly straight. Okay, so I think we have a winner here. Now I need to change this. I need to realign this and then start machining with this guy and making those features. In the first pass you can see how out around it was, but now I'm gonna make it align. Let's see where we are approximately. I'm gonna measure with my counter when I get closer. I need to reach 8 mm 5 microns. I'm at 11 mm 40 microns. Keep going. We are hot. I have to wait to cool it down. 1035. Okay. Let's do some math. 1035 minus 8.1. So that's some average there. Divided by 2, divided by 2.0254. That's 1000 inch. I have to go 44 divisions on the dial. Okay, so it's 5. Okay. I hope that okay. 10.07. 10.07 minus 8.1 divided by 2 divided by 0.0254. 30 degrees. It's 5. Okay, be very careful so I'm not overshooting this because I'm not seeing myself pulling this out. And start another 992. Okay. Okay, until I make dimension. This is complete now. Let's see the run out. I would say it's, I don't know, 5 microns at the end there. Pretty good all the way. That's where the bearing will sit here. So now I need to make a metric 4 here for the screw. I need to tram the spindle, meaning needs to be perpendicular to the table. I mounted the disc, the slotting disc. I have this huge clamp so I can loosen the 3 bolts which are holding the head and adjust it, because as you can probably see, that needle should not move, or not that much, so I'm off by a lot. So I have to align this and then look at the cable. This cable, and then I can proceed. Seems it worked. Cut it nice. I need to make one of these again, a new one, to cut the other side, to turn this 90 degrees and do the other cut. So I'm gonna do that next. I managed to cut this, drill the first hole through this plate, through the hub on the other side and through the plastic fan. And I put a 2.5 millimeter to align them, because I'm gonna rotate this 120 degrees. I have this hexagonal fixture here and this top, so it comes to the same position. Just unscrew this, rotate 120 degrees and do the other three, and then I have to tap the 3 holes on the bottom and enlarge these holes to 3 millimeter for metric 3. These screws I'm gonna use metric 3 flat head, and we'll go from there. Hey honey, the good news is I tightened this and then released it, so it's clamping rock solid. I cannot move this, like nothing. It's so solid. So much grip on that bushing. Now I need to use a puller to, that's why I left this space here, so I can pull it out, right? Press on this and pull it out. But it worked. It's like crazy solid. Here is the hub complete. And this gonna get tightening that taper. I'm not gonna put a screw because then I need to pull it with a puller again, because it grips so well. But even so, it hand yeah, it spins a bit because it's not tightened. But when it goes on the motor and I use that metric 4 screw, it's not gonna go anywhere. But looks balanced. I mean, don't look at it because this is not round, but look here on that ring around the shaft. Looks balanced to me. Moment of truth. Need to hold the wire. I hope you can see.